Welcome everybody and good morning. Welcome to day 2 of the .NET Conf. This is going to be a post-conf workshop. This is going to be a deep dive into the topic of the day, and that is microservices. Both myself, Rob Vetter, and Manu Bambrew are going to present this to you. This is going to be more of a deep dive in microservices and hosting microservices in Kubernetes. So again, today we're going to really talk about architecting microservices. We're going to build a conceptual understanding. We'll talk about the design, the architecture. We'll talk about patterns, principles, best practices. We'll kind of give you an end-to-end story, if you will. We'll do a little bit of on-ramp, and then we'll begin to move through the process. We'll talk about modeling, how you might model your domain to build a microservice application. We'll get into some key architectural concerns like service design, backing services. We'll talk about communication between front-end clients and back-end microservices. We'll talk a lot about data, this idea about distributed data. How do we deal with that? We'll talk a bit about resiliency, and then we're going to get really deep into a lot of the Kubernetes hosting topics on the back end. So again, we want to raise your awareness. We want to go deep. We want to help you get started. Please give us all of your questions, if you will. We're really interested to know that, and we will promise to get back on each and every one. So again, my name is Rob Vetter. I am a principal cloud native architect with Microsoft. I've been with Microsoft for about 9 years. I do a lot of work these days with customers around distributed cloud native microservice systems. I've got quite a bit of depth in microservices, containers, a lot of Azure PaaS, platform as a service, and quite a bit of, I'm a subject matter as well in the ASP.NET stack. So things like ASP Core, Entity Framework, those kind of things we can help you with. I want to point out something that I think would be very helpful, and that is this book right here. So you may not know this, but Microsoft has a really nice collection of guidance books. So don't do this now, but if you go into a browser and just type in Microservice, Microsoft, make that, how's that, architecture, just like this right here. What you come up with, the first link should be .NET Application Architecture Guides. These are there are many of them out there, and they're very, very helpful. You see, we have guides on microservices. This book's been out for about 2 years. It's really very well done. There was a lot of work put into that. We have guidance books on DevOps, mobile apps, ASP, cloud, you name it. Here are some of the more current ones. These are the more recent. We have one on modernizing desktop applications to use .NET Core 3.1. Here's one. Look at this here, gRPC for WCF developers. Great book on gRPC. You should, at the very least, read the first chapter. You should be very well versed in what gRPC is, because there's a good chance you'll be seeing it very soon. Here's one for Blazor. Here's one that I helped, that I co-authored with a gentleman named Stephen Smith. It is called Architecting Cloud Native Apps for Azure. All these books are the same. If you click on one of these things, you can read it. You can download a PDF, or you can read it online. Everything is right there to read. I would recommend 2 things. One is read the first chapter. You should understand exactly what a cloud native application is. There's a lot of marketing these days, you know, that everything's cloud native, but this particular chapter will explain to you exactly what a cloud native application is, based upon, not my opinion, but based upon that of the opinion of the Cloud Native Computing Foundation, who really is the guiding organization for cloud native going forward. A lot of the topics that we talk about in here, in our workshop, will be in here. You'll see things on scaling, communication patterns, distributed data, cloud native resiliency. So again, it's a free book. Take advantage of it. Notice these are not paperback. These are soft cover books or online. And again, the reason why that is because this stuff changes so quickly. And what we can do, making a soft cover sort of online, is we can change quickly with it. So these are constantly being updated. So again, take a look at these books. They're out there. There is one here, I think, someplace, if I can find it really quickly. Yeah, look at this here. Here's one on serverless apps. Jeremy Likeness and Cecil Phillips, they're both cloud developer advocates. Again, really nice pass talking about serverless apps, the architecture, the pattern, and how to implement them in Azure. So again, take advantage of these things as well here. So back to the content. Okay. We also have Manu Bambrew. Manu, want to say hi to the audience? Say nice things. Manu? Maybe not.
Oh,
you go right ahead. Okay.
Hello, friends. Welcome to this day 2 of .NET conference. My name is Monu Bambru. I'm a senior consultant, architect in Microsoft. Been in Microsoft for about close to 14 years now. I live in Seattle, Washington. So just like Rob, kind of specialize in cloud native architectures. Have done, quite a bit of work over the last, 5-6 years with customers on, Azure solution architecture, cloud native architecture, do a lot of work, within Kubernetes platform, microservices, Docker containers. So today I'll be talking about Kubernetes and containers and kind of running the modules on those. So yeah, thank you.
Perfect. Thank you so much, Manu. So again, today, our approach, we're going to give you a lot of conceptual material, technical slide decks, not the marketing stuff, but we're going to go fairly deep into that, right, too. We'll look at a lot of demos. So as we talk about the stuff conceptually, we'll show how it works. We'll show you the code. We'll walk through code in a debugger in some cases. We're not going to have as much discussion probably because of the format of this, but I please want you to please post your questions and your comments because we look forward to your feedback and we'll make sure that we address all of your questions. Before we get started, one more thing, a big thanks to Jeff Fritz, Beth Mazzy, Nish Anil, Scott Hunter. They help make this happen for us and really appreciate that. You don't see them, but behind the scenes, they're working hard to make all this happen for you.
Absolutely.
Here's the agenda, guys. Okay, we're going to start with an on-ramp of microservices. I know we talked about it yesterday. We'll just do a really quick, get on the same page. I want to talk about modeling microservice systems. That's a key piece. Before you start coding, you need to really think about, well, what is our system going to look like? And if we're going to take a domain and break it down into microservices, like how might we approach that? So we'll talk about that. There's a lot of architectural concerns. I want to hit on a few key ones. We'll talk about service design. We'll talk about backing services. We'll talk a bit about monitoring. And then we're going to get into, oh my God, I don't have my communication. I'm missing. We'll talk about microservice communication. That should be in here. We'll talk about how front-end clients communicate with back-end microservices. And more importantly, we'll talk about how back-end microservices communicate with each other. Again, those are key topics when you're building a distributed application. We'll talk a bit about distributed data. We'll talk about how, if each microservice owns its own data store, well, then how on earth do we do a query across multiple services? And even more importantly, if each microservice owns its own data store, how do we do a transaction across multiple services? Because you know what? We don't have ACID transactions. We don't have a distributed transaction coordinator. How do we do that? We'll talk a bit about time permitting, about high volume data. We'll talk a bit about CQRS as well. That's a common pattern. Talk a bit about resiliency, and then we'll get into Kubernetes concepts with Manu. He'll talk about Kubernetes, why that's important, how that plays into microservices. We'll show you our microservices application hosted in AKS. And I think time permitting, Manu, maybe we'll talk about some of the more advanced things coming down the pike, including service meshes.
Absolutely. And Rob, just to add to that, so obviously we'll be looking at some of the microservices patterns, and hopefully we'll have time to kind of show you some of the abstractions available on top of Kubernetes platform where we can show you how, as an example, service meshes like Linkerd and Istio work well with AKS, show you some of the concepts around, circuit breaking, canary deployments, the layer 7 service needs, which are not typically available with your platforms, as is, how they can be kind of leveraged through these service mesh architectures. So definitely looking forward to kind of interacting with you guys and fielding questions on some of the mesh platforms we have, and also talk about some of the Microsoft's point of view on service meshes. We have a spec for service mesh already out there, so obviously go through some of those aspects as well.
Really, and I think that's really important. And again, what a service mesh is and why it's important, and the role they're going to play in your future. For sure. So again, this is the topics. Keep in mind, we have been doing a customer-based workshop for Microsoft customers on microservices and Kubernetes for quite a while, maybe about 2.5 years. So again, we've been doing this for quite a long time. This material is part of that, and the product teams have given us, there's a lot of new material they've given us as well, so I put it all together here. We have more material here than we can possibly cover, so you may see me kind of skipping through slides, but you will have all the slide decks, and we'll make available all the code as well too. So again, these are things that I think are going to be important to you. This is going to be our end-to-end story. I hope you like it. Let's do it, man. Enough talk. Huh? Okay, let's kill that deck. Let's get into our on-ramp deck. Should be right over here. I love it. It's an interesting graphic, isn't it? A little recursion going on for you there. Okay, here we go. So let's talk about microservices. Now, again, if you were on the conference yesterday, there was a lot of talk about microservices, a lot of really good sessions. I just want to kind of bring it all together and make sure we're all on the same page. I don't want to spend too much time on this. I do want to talk about also the benefits and the challenges. Because again, we have customers who say, hey, come on in guys, tell us about microservices. And we step in the door and they say, hey, we decided we're going to build everything in microservices. And we kind of think, well, that's a great thought, but that probably won't happen because not every application is really going to be a candidate for a microservice architecture. So we'll talk a little bit about that too as well. So again, let's level set. Okay, here's the thing. So if you ask 10 people, 2.5 years ago when we first started doing this, if you asked 10 people what a microservice was, you got 10 different answers. Now, fast forward 2.5 years, if I ask 10 people what a microservice is, I'll get about 7 slightly different answers. 3 people will be completely, again, people are beginning to understand it, but let's start the whole thing off by agreeing on a common definition of what this even means, right? So I'm going to give you a very verbose definition. I didn't make it up. This is what I've gathered over the 2.5 years. And again, I've done a lot of research. I've been immersed in microservices and cloud native. So again, here's what I found, okay? Microservices are, here we go, an approach to system development in which a larger application doesn't need to be large, but typically they are large, because if we microservice a smaller application, we may not get the benefit out of it that we really want. So typically, we develop a larger application as a suite of small modular services. So again, think of a large application being a suite of small modular services. Each one of those services supports a specific business goal or capability. So a single concern. So we're going to use an example throughout of an online store because everybody understands the online store, right? So we're going to have an online store. Example here might be we may have a separate service that does nothing but show you what's in our product catalog. Another service that basically manages your shopping basket. Get alone another service that helps you build orders. Another one for shipping, another one for inventory, so on and so forth. So again, we sort of move from something you might be very aware with. I love this here. The single responsibility principle. Remember that in Solid? A solid principle, a class should have, one reason and one reason to exist. We're looking at it now maybe as a single concern principle. So we're going to say a microservice should have one reason and primarily one reason to exist. So again, it's really important that we break our domain into smaller services, and those services really should target capabilities. We'll talk a little more about this in just a little bit here. Each of those services, again, here's something key. They're fully independent. So that shopping cart service, that product catalog service, that ordering service, they are independent. They are self-contained. They have their own code, their own data, their own dependencies, their own state. They are independent, and that's really important. Okay, each one of those services is going to expose a well-defined interface so that it can communicate with other back-end services and especially with front-end clients, or some kind of gateway that will basically be between our front-end clients. And we'll talk a lot about that. They'll think of a standalone self-contained service with an interface that basically says, here's what I do, you can communicate with me, right? That interface can be exposed either over some platform agnostic protocol. Typically REST is what we've seen for years and years, but now we'll talk about and we'll show some gRPC. We'll see that gRPC is an alternative to REST, and it has a very strong story, and it has extremely strong support in the .NET 3.0 and above library as well. So I think you'll see more and more and more backend services communicating with gRPC. These services, this is interesting, they could be implemented across different technology stacks if desired. So we could have a large organization, we have .NET teams, we have Java teams, we have Go teams, we have teams building in Python. We could bring those teams together. Each of the teams could build in their expertise, their platform of expertise, and it would work because, again, we're communicating across those services. Remember that platform agnostic protocol? So again, when we're doing that, we need to think about, well, how can we support a service that has multi-languages? But again, we can build cross-platform applications or cross-platform services. Here's a big one. See this big sharp curve ahead? Because this basically rocks a lot of people here. Each service should, by definition, encapsulate its own data. So what does that really mean? If I'm the product catalog service, I encapsulate my data. It's inside me, so to speak, right? I'm not sharing that data. And then if I'm the product catalog, if I'm the shopping basket service, I encapsulate my data. And if I'm the ordering service, I encapsulate my data. So what we end up with is a service with its own data, and that service selects the appropriate or best underlying data store. For example, maybe the product catalog says, you know what, my data best represented maybe in a relational database. So maybe it uses Azure SQL. Maybe the shopping basket goes, you know what, I've got a very simple data schema. Why don't I just use a Redis cache to represent my data? So maybe the shopping basket has a Redis cache backing data store. And maybe the ordering service says, you know what, I can really excel if I were to use more of a NoSQL document approach. So maybe the ordering service uses a Cosmos DB NoSQL database. So again, each service has its own data by definition, and then each has its own database or data store. Now, you might say, this is usually where the hands come up and people say, what are you talking about, man? How can we have a different data store? We'll talk more about this later on when we get into distributed data. But again, and there's no federal law forcing you to do that, but that is by far the best practice, moving away from that single shared database into separate data stores. And we'll talk more about that. We're not done yet. Each service, and this is probably the key slide here in this deck, each service can evolve independently, and each service can deploy frequently. So if I make a change to my application, say the pricing engine is broke, I make a change to it, I'm not deploying the entire application, I'm deploying the pricing service only. And you know what, if you think about an e-commerce application, good chance the product catalog is going to evolve a whole lot more rapidly than the pricing engine service, than the ordering service. Why is that? Because, if we're a online music store and we're competing with Amazon Music, we're competing with Pandora, we're going to evolve that, when they make a change, we make a change, vice versa, right? So again, certain things are going to need to evolve more quickly than other things, and we can do that with a microservice architecture as well. Here's the final slide. All these services, they compose together to form a single application. So really quick, that was a lot, but hopefully this has helped. Again, what is a microservice? An approach to building systems, a suite of small modular services. Each service supports, again, that specific business goal, if you can. Each service is fully independent and self-contained. Everything is inside of it. It's not sharing. Each service exposes a well-defined interface to communicate. That can be exposed. We could expose a REST interface. We could maybe ideally expose a gRPC interface, right? Services can be implemented in different technology stacks. They don't have to all be Java or all Go or all .NET Core, if that makes sense for the organization. Each service encapsulates its own data. Each service can evolve independently, deploy frequently, and they all compose together to form an application. So hopefully that helps put us all on the same page. So now, here's the big thing. Look at that little phone in the upper right-hand corner, right? Your phone rings. It probably used to ring. Maybe it's not ringing so much now, but it will again. And who is on the other end? It is that friendly recruiter calling you every day saying, hey, I've got a new job for you. You're going to love this job. You're going to love this job. You're going to love this job. Well, you get a call from a recruiter, and he goes, hey, I got this new offer. You're really going to love this. Check it out. It is a startup. Lots of venture capital funding. Big, a lot of big names. We are going to build the next generation e-commerce application. We're going to compete with Amazon. We're going to compete with Walmart. We're going to compete with Target. So you go, wow, that sounds really good. And then the recruiter goes, hey, dude, microservices, containers, Kubernetes, lots of stock options, a big sign-on bonus. And you say, you know what? I got to go. So you get hired. It's your first day on the job. You're all together. Everybody's new. You're in that big conference room, if you can picture this. And here's the big question. The million-dollar question is this. What is going to be, if I can find mine here, what is going to be your design? Wow, how are we going to design this thing, right? Now, what's interesting is if you adhere to the guidance from the past 15 years or so, what you'll probably end up doing is this. You'll end up creating a large core, if you will. Let's look at this right here. It's a large core application. It will contain all of your business logic, your data logic, the front-end logic. You'll end up with a shared relational database. This is typically what we've been doing for a long time, right? You have a catalog module. You have an ordering module, a basket module, location, marketing. And again, they're all running in the same process, and they're all getting data from that very large shared relational database, and they're basically going to render HTML and REST from the front end. This is fine and dandy, okay? So you build the application just that way, because again, this is what we've been doing, right? You package it, you deploy it, it's out there, you're in business. So what are the takeaways? What did we just do? Well, we built an application. We followed the very popular guidance that we've been following for many, many years. It's layered, right? We have a business layer, we have a data access layer, we have a UI layer, so we have some separation of concern there. But again, everything runs together. All this is running in a single process, right? So again, congratulations, you just built a monolithic application. And I think Brendan Burns said this yesterday as well, too. And listen to him because he's really good. But Brendan Burns says, you know what? Just because you build a monolith, it doesn't mean it's all bad, right? If you think about monoliths, it can be very straightforward with monoliths. It's straightforward to build a monolith. Everything's together. It's fairly straightforward to test that monolith. Because again, if I'm doing an integration test and I need to talk to the catalog, I need to talk to the basket marketing, everything's right there, right? They're very straightforward to deploy this thing. What do? I basically deploy the entire thing out. Press that publish button, or put my CI/CD and push it out, right? It's fairly straightforward to troubleshoot. Again, if I'm having an issue in one component, I can troubleshoot and step into another one because they're all running together, right? And it's extremely straightforward to scale. I can say, here's one instance of my monolith. Oh, I need another one and a third one and a fourth one. I put a load balancer in front. So again, life with a monolith is fairly straightforward, right? Performance can be good because everything's running in a single process. We're not doing out-of-process calls on these things. So you build this, you deploy it, you're running it. It's a big success, right? And then what are you doing? You are basically building it out step by step by step. You're having 3-week iterations. You're building more and more and more stuff. It's a big hit. It continues to evolve. Over time, you may find yourself losing control sooner or later of the application, and you may enter into a state called the fear zone. And if you've been in this industry, you probably have been in the fear zone more than once, right? So what is a fear zone? You're in the fear zone. You're in the fear zone when your application has become so overwhelmingly complicated that no single person really understands it anymore. And here's a big characteristic of the fear zone. You dread making changes because you know that each change will cause unintended and costly side effects, right? What does that mean? Well, the business owner goes, hey, you got to fix X. X is broken. You say, no problem, I'll fix X. You fix X, you redeploy the application, and inadvertently, Y and Z break. Owner goes, what are you doing? You fixed one thing, but you broke other things. And you say, well, I don't know, but I'll fix Y and Z, and you do, and everything's working. Then the business owner goes, hey, we need to add some new functionality. Okay, you know, we're competing against Pandora for a music store. They just added A. We need to add A as well, too. So you add A to the application, and then you break Y and Z again, right? And you get into these patterns of collateral breakage or cascading breakage. And why is that? Well, everything is so tightly coupled together. When you make one small change, you're not really sure what is going to break, right? So what happens then? Well, fixes and features raise your anxiety level, right? They're time-consuming, they're expensive, they're to fix or create, they're error-prone, right? So you spend your time, instead of building stuff, you spend your time pushing back on changes. And each change becomes as small as possible. So instead of building innovative, cool apps for your customer, your time and your IT budget gets sucked up in support. Because every time you look at the application, something breaks. And I think you've probably been there. But there's even more, right? What about this? In a monolith, each change requires what? A full deployment of the entire application. If I fix one line of code, we're charging the wrong price for for an item. Is a simple one-line code fix. That's a full deployment. And what do we know about full deployments, right? They're a big deal. They don't happen very often, maybe once a month, once a quarter. It's probably on the weekend. We have a bridge set up, all hands on deck. We're probably bringing the application down to do it. And again, if you're the lucky person who has to press that publish button, you're always thinking, man, what are we going to break now? Man, did we test everything right? So again, not pretty, right? One unstable component can crash the entire application because it's a monolith, right? If your exception handling isn't good, you can have very unpleasant surprises. Can you implement new technologies and frameworks in a monolith? Not really. If everything's built in .NET framework, it's going to be very hard to implement .NET Core into the same application or other frameworks or other languages. And here's a big problem. Since everything runs together, the architectural erosion over time sets in. So what happens, you're doing these one-off fixes and one-off enhancements and one-off fixes. So the code base becomes more and more tightly coupled together. And eventually, you know what happens? The consultants come in and say, hey, man, we got to rewrite this thing. So this would be the fear zone. And my guess is if you've been in this industry, you've been there. And here's really the sad thing about it, I think right here, is when you're in the fear zone, your IT budget is getting sucked up into support. You're not able to build lots of cool, new, innovative apps for your customer because you're doing this. That's not a good scenario. It frustrates you. It frustrates your business people, and it certainly frustrates your customers as well, too. So looking forward, okay, many organizations are mitigating or looking at mitigating the fear zone heartburn with an approach of building applications in microservices. So kind of overlay this picture right here. Let's go back for a second. So here's what we did build. We said we're building a new application. We have this big monolithic server process. We have catalog module, basket module, marketing module, all running together, right? What if we do this? What if we say, same idea, but now the catalog module becomes a standalone, isolated service, as is the ordering service, as is the shopping basket, as the marketing. So now these are not components. These are services as well, too. Look at the architecture. We'll talk a lot about this today. So here we have our services. Again, these are independent services. They're communicating with each other over a network. They're not in process anymore. Notice the different data stores. We'll get to this later here, but notice maybe the catalog, it basically consumes the relational database, as does maybe the ordering service. Here's the shopping basket or Redis cache, maybe the locations microservice, maybe a NoSQL. So again, since each microservice owns its own data store, it can choose or select the data store that makes the most sense. We don't have to have a relational database for everything. Notice this event bus thing. We'll talk a lot about communication or messaging, but you can see many times it's a better practice. Instead of having one service directly talk to another, can we send asynchronous messages back and forth? And we'll talk about that. Look at this gateway thing. We'll talk about that too. Notice the front-end clients here, the mobile app, the traditional web app, the spa app. They're not talking to the services. They're talking to this front-end API gateway. So we'll talk a lot about that as well too. But this would be more of in fact, this is a microservices approach. And again, just one more, take this picture really quick in your head and contrast that with this right here. And you can begin to see some of the differences right there. By the way, this is a take. We'll talk about some reference applications Microsoft has available that are microservices. One of them is called eShop. We'll talk about it in a little while, but eShop is a full end-to-end reference architecture that built really a couple of years ago, and it's been maintained very well. It is an online store. It is a microservice-enabled application. We're going to show you one that's very close to eShop. I like to think of it as eShop Lite, and we'll make all that code available. So all these slides, all this code will be available to you as well, too. So anyway, question for you in the audience. Look at this right here. Is that a microservice application? What do we have here? We have an application that looks like a UI layer. Maybe this is maybe a .NET MVC application. We have a business services layer, a data services layer, a database. Is this a microservices application? Well, no. This would be more of your garden variety web app. Again, nice separation of concerns. If you see here, we do have a UI layer with all the UI stuff, separated from all the business logic, separated from all the data logic. But again, notice that in the business services layer is all of the business logic. So we have the shopping cart, we have the ordering, we have the inventory all together. So not really a good microservice story here at all. What about this? You might say, well, we're not building this. We're building this right here. We're building, look at this here. Oh, we have a service facade. Isn't this cool, right? So now we're exposing we're exposing endpoints, and we have a web app. We have web clients and mobile clients and desktop clients consuming that. So is this a microservices application? And the answer would be no, not really, because again, even though we have a nice separation of concern here, in our business services layer is everything business. In our data services layer is everything data access. So again, better, more clients, but again, I'm going to call this my garden variety API application, if you will. What about this? Is this a microservice application? So we have these product catalog, shopping basket, ordering, payment, shipping. Yeah, obviously this would be more. Why? Because we have isolated, if you will, self-contained back-end core microservices, the product catalog, the payment, the shipping. We have the gateway. We'll talk about that. You'll see a lot of the interaction when we can. We're doing asynchronous calls here. So we'll talk a lot about this. This is like, by the way, the code we're going to show you looks just like this as well too. So again, let's keep going. Let's just touch upon why we even care about this. So we're getting into this nice expose on microservices versus monoliths and all that, but why do we care about this? Let's just touch upon the benefits and challenges of this stuff, okay? So my question for you, look at this here. How agile do you think this is? I've got a single code base, a single release pipeline. I got 4 development teams. So maybe development team A, they're the product catalog team. Maybe team B is the inventory. Team C might be the shopping basket. Team D may be the customer information. They're all sharing the same code base, right? So what does this mean here? Well, that means they're going to be tightly coupled, right? Because everybody's sharing the same code, sharing the same dependencies. They're also sharing the same release cadence as well, too. So if we need to do a release, everybody has to be checked in. Everybody has to be building correctly. So again, what happens if dev team A breaks the build? Well, there's a good chance that they may break you because somewhere in this code base, you're going to be coupled to them. And certainly if dev team C, who maybe owns the pricing, if they need to deploy, well, they're not going to be able to do that because the build is broke, all right? So let's contrast this maybe with this approach. So here are the dev teams, A, B, C, D. It each has its own code base. So they've isolated their code base and not sharing directly dependencies, right? So what happens here now if so each also, by the way, has its own release cadence, and each service can deploy independently. So if dev team A breaks their code base, but dev team C, the pricing engine, has a fix out, they could effectively make their change and push it out without worrying about dev team A so much, as long as the interface between these two isn't broken. So you can see that, I don't know why it's advancing. Each team can deploy independently. Each service has its own release cadence. So who are some of the big customers doing this, right? So let me ask you, look at Walmart. Is Walmart agile? When I say numerous services, I'm talking about many, many, many microservices deployed in production. Walmart claims to make over 30,000 changes per month to the back-end services. Think about that, 30,000 changes per month, right? That's a lot of changes. If you divide that by 30, do the math, okay? What about Netflix, another one? They claim to have more than, and this is probably about a year and a half old, so I'm sure it's even bigger than this. Many, again, 600 or more services in production. They claim to deploy hundreds of times each day, and your buddies over at Uber the same way. Lots of services. They claim to deploy every minute during their work hours. So these companies are agile. Now, you may not have the volume that Walmart, Netflix, or Uber has, but you know what? But you can see the agility that they're getting on this as well too. So how important is agility? Again, probably the biggest benefit, I'm going to guess, I'm going to run a limb here and say of a microservice architecture is agility. The systems can closely align to the business capabilities. I've got a pricing service, I got an inventory service, a shopping basket service, very closely aligned. They can rapidly respond to market conditions. If my competitor makes a change to their catalog, I can make a change to my product catalog and push it out quickly. I can instantaneously, this is important, I can instantaneously update a small area of a live application without taking the application down. I'm not waiting until the end of the month, end of the quarter. I can make that change now, and I can even roll that change out. I'm basically I have 15 instances. I'm basically making those changes, one at a time, so that way my application remains in production. It remains live. And again, I can evolve my app service, my services independently, and I can deploy them frequently. So agility is key. But you know what? There's more benefits for us too. Again, we talked about this earlier. With the microservice architecture, I can sometimes reduce some of my maintenance costs because my updates, my fixes target a single service, not the entire application. I can also get fine-grained scalability. So if I need to scale my online music store, think about this. Do I need to scale the whole thing? Probably not. Good chance with any online store, you're going to be scaling the product catalog the most. Why is that? Because people are browsing more than they're buying. So I may need 15 instances of the online catalog or of the product catalog, but maybe 5 of the shopping basket, and maybe 4 of the ordering. So with the microservices, I can basically get that fine-grained scalability. I can scale services independently. With a monolith, I got to scale everything out 15 times, even though I don't need everything scaled out 15 times, and I'm paying for resources I'm not really using. Right? What about stack lock-in too? If I can build my services in different technology stacks, again, I can optimize my agility by mixing heterogeneous platforms and data stores, and I can also future-proof my application investment against obsolete technology stacks. I could say, wow, here comes .NET 5. That's coming out soon enough, right? And there are some things in 5 we could really benefit from, but I can't rewrite the entire application in 5, but could I build a business case to rewrite maybe one of my services? I want to write the pricing engine in .NET 5. It'll take me 3 weeks to do that. Here are the benefits, faster, so on and so forth. So again, I hate when my slide advances for me without me doing it. Again, that helps. I can increase resiliency. I can release with confidence. I can isolate failures to a specific service. Here's an interesting slide, really. This is from an O'Reilly. We know O'Reilly Publishing. They did a poll just recently of about 1,500 people for microservices. This is what people said, okay, or this is what customers said. What benefits, if any, has your organization experienced from moving to microservices? Look at this here. Feature flexibility, wow. Responding quickly to changes in the business requirements. Better scalability, more frequent code releases, okay, improving developer productivity, right? Easier and more complete testing. So you can see here pretty much that a lot of the things that we're talking about mirror the survey of these 1,500 people. So that's fine and dandy. We're beating the drum for microservices. We're saying, hey, this is great. You should do this. But really, think about this, though. Lots of challenges with microservices as well, too. There's no free lunch, right? You know, microservices are distributed systems. And distributed systems are always going to be hard. And, you know, I've got something set in this slide deck where, notice how, without me touching it, the bullet points are popping up. So again, here are the challenges. Your architectural and your operational complexity, they dramatically increase. What was once simple becomes complicated, okay, or can become complicated. Your in-process call stack, where everything runs together, is replaced with network calls. Now when one service calls another, it's going across a network. Now we're introducing things like network congestion, latent, partitions, transient faults. Again, we have to deal with that, right? The data now becomes distributed. So if each service owns its own data, what does that mean? Well, we're moving from an immediate consistency more to an eventual consistency model. So this becomes more complicated. Versioning becomes complicated. It's not just version 3.2 of the entire application. It's version X of one service, version X plus 3 of another service, version Y of another service. Again, service discovery, routing becomes really key. You saw yesterday, there is a framework Microsoft is working on. It's called TIE, T-Y-E. That framework is going to help you deal with service discovery and routing. That's huge because service discovery can be really a lot of work. The automation, here's a big thing too. Automation, orchestration, and monitoring, these all become mandatory. So again, you have to be able, please stop. I don't know why my slide deck's advancing for me. Anyway, I didn't. So anyway, sorry about that. It's throwing me off. So again, same poll, challenges. People found challenges. The culture, they said, is a big challenge, and that's true. You need to really you need to have a certain mindset and a lot of understanding in order to do this. Your DevOps needs to be really good as well too, because you're not going to be manually pushing these things out, right? The design, we'll talk about that next. That can be challenging. Dealing with legacy systems that increase complexity. So you can see too, again, hiring microservice savvy staff. So again, you can see that these are some of the challenges as well too that people find with microservices. So again, here's a slide from ThoughtWorks. ThoughtWorks is a premier IT consulting firm. I'm sure you've heard of them. They are thought leaders, I think, in the industry. They have a slide they call the Microservice Premium. I want to show you this. They claim here pretty much that if you look at a system for a less complex system, the extra work of microservicing enabling your application will probably far outweigh any benefit you'll get from it. But as your application increases in complexity, it gets bigger, it gets more complicated, then moving to a microservice architecture, you'll really begin to see the actual benefit of that. Something to think about. So that kind of leads us to this question. This is the last one on this slide deck. Microservice candidates, right? So if we have applications, what's a candidate application to become a microservice? Whether it's a new application or whether it's going to be an existing application. You might think of it this way. If I have complex applications that are key to the organization, they're enterprise or critical, but they're difficult to manage and maintain, that may put them into this particular bucket as a candidate. Strategic systems that need to closely align with business capabilities and features, again, that may make them a candidate. A system that requires a high release velocity. We're going to be releasing all the time. We need to be able to do that with high confidence. And again, we need to be able to instantaneously update small areas of a live application without bringing it down, right? if we have systems that absolutely require heterogeneous technology, you know, we need to build some in Java, we need to build some in Core, that's just the makeup of our teams, again, they could be a candidate. And again, if we have applications with components that absolutely must scale independently, that as well too might make them a candidate. So again, it's not every application is going to really be a good candidate for a microservice. So again, these are applications I think that tend to play well. So again, we talked about microservices. It's 12:06 my time. Let's move on. Do we take a short break yet? I think we're talking about taking a number of short breaks today, so everybody can get up, get some coffee, get to the restroom. Let's maybe do that now. We've been going for about an hour. Let's come back in 10 minutes. I want to talk about modeling services just a little bit. You know, how do we take a domain? How do we decompose that? Then I want to shift gears, talk about some key architectural concerns you need to be thinking about. I'll talk about communication, talk about data resiliency, and then we'll get into the cool stuff, and that's going to be the Kubernetes and AKS stuff. So let's go ahead and take a break. I can set a timer if you like here. We can go to the online, the handy dandy online stopwatch right here. Let's bring it up. Let's set it. We'll come back in 10 minutes. Let's do a countdown for 10 minutes. Get some coffee, get some water, get some fresh air. Please come back. We will rock and roll in 10 minutes.